Hey, yo, 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 yo. Hope everybody's doing well. Thanks for tuning in. Let's get into systems of equations by substitution. Okay, so basically what we're going to do is we're going to look at solving systems of equations algebraically. Graphing is not always the most fun thing to do in the world, and it's also not very efficient, and sometimes it's also not very accurate, especially if our solution is not a perfect point. So this is where we like to solve algebraically just by solving equations. So we're going to solve, if you have not watched 4.1, which talks about what systems are and solving by graphing, watch that first because you need to understand some stuff from that before we get into here. So here I have a system, and I want to solve this not by graphing. Now I could graph this. I could write a coordinate plane. I could graph 6x plus 7. I could convert this to slope-intercept form and graph that. But this would be a really good example of why I don't want to graph. And because if I were to convert this to slope-intercept form, right away if we look, the intercepts aren't going to be perfect points, they're going to be fractions, which isn't very nice. So if I try to convert it to slope-intercept form, maybe I'll have a nice easy graph to work with, but if we look, I'm not going to. I'm not going to have, my y-intercept is going to be 1/2. So it automatically makes it a little bit of a difficult graph to even start with, but then when we're finding the point of intersection, it's not going to be something, might not be something friendly. It might be, we don't know, but it's going to be hard to really have an accurate graph there, and it's going to take a lot of work. So we're going to work on substitution. So here's what we do. If we notice, we have a variable isolated and solved by itself. Y equals 6x plus 7. And then I have my second equation, so this one's in slope-intercept form. This one's not, but that's fine. But I got y equals something, okay? Whenever I have y equals something, all of this is what y is. 6x plus 7 is equal to y. So beforehand, if I said y equals 2, you would be able to take that 2 and just plug it into an equation to solve. Okay? We've been able to make substitutions with single numbers before, and it's never changed anything. So you'd be able to do like 3x minus 8 times 2 equals 4, and then you would solve this equation for y equals 2. We've done that. We're going to do the same thing. So I know what y is, but instead of y being a single number, y is a mathematical expression right here. It's 6x plus 7, but I can still make that substitution for y. So I can replace this y, because I know what this y is. This y is equivalent to 6x plus 7. So I can rewrite my second equation here with a substitution of replacing y with what I know y to be. I know y is equal to 6x plus 7, so I replace this y with 6x plus 7. And notice how I made my substitution in parentheses because this is multiplication. By doing this, I only have one variable now. We haven't been able to solve equations with two variables, but I can solve an equation with one variable. So now I can actually follow my steps of solving an equation, and I can solve this. So I can do distributive property here and solve. I can combine my like terms. That's negative 45x minus 56 equals 4. Let's see here. I'm going to add 56 to both sides. I get 60. So then when I divide by negative 45, I can do that division, or I can leave it, I can just simplify it as a fraction. It doesn't matter. If I divide by 5, I know that's going to give me, 12 over 9. I know my answer is negative because I have a positive divided by a negative. And I can even simplify 12 over 9 even more by dividing by 3. And so that's going to give me 4/3. So x is equal to negative 4 over 3. Now the reason why fractions are actually nicer in this regard especially is because this is a repeating decimal. So if I use it as a decimal and I use that decimal to substitute into, if I use that decimal as my second equation, and you'll see why in a second, it's not going to give me the exact answer. So fractions are more exact than decimals, especially when we have repeating decimals like thirds. So leave it as a fraction. Let's get in that habit. So what I did is I figured out, that looks like a y. I figured out what my x is. So now I know for these two equations, the x that works for both of them is negative 4 over 3, or negative 1 1/3. So what I can do now is I can take this x and I can now make another substitution, because I know what x is, and I can plug it in for either x in the second equation or x in the first equation. And it does not matter where I plug it in. Doesn't make a difference. So I'm making another substitution. So once I solve for x, I can plug it in either equations, because we know that this x is on both of these lines. This is an x coordinate that's on both of them. So I can plug it in my top equation or my bottom equation, and I should get the same answer for both. That's the point here. And so that's why it doesn't matter which one I plug it into. It should be the same answer for both, because this is that point of intersection. So let's plug it into this top one. So I get y equals 6 times negative 4/3, because that's what x is, plus 7. Well, this worked out really nicely. I have 6 and 3 cross simplify. So this is just 2 times negative 4, which is negative 8, plus 7. That's negative 1. So y equals negative 1. So there's my solution to my system of equations, negative 4/3, negative 1. And I'm done. There's nothing else to do. I have an x, I have a y. That should work for both. Now let's just show what happened if I used it for my second equation, just to prove that it doesn't matter which one I choose. So I have negative 4/3 minus 8y equals 4. These 3's cancel. Negative 4 minus 8y equals 4. Add 4 to both sides. Let's see, I get negative 8y equals 8 divided by negative 8. Y equals negative 1. Got the same answer. So that's another way to check your answer. If you get the same answer both times, then you know for sure you did it correctly, because this is the solution. And that's it. So let's look at some more examples. So here's a word problem. It already gave you the system, but let's talk about how they came up with this system of equations in this particular word problem. If a person takes a surfing lesson and goes parasailing, they pay a total of $175. So if they take a surfing lesson and go parasailing, so that's if they do one of each, they pay a total of $175. So if I go surfing and parasailing, if I add up the total cost, I'm going to get to pay $175 total. Well, the resort on Friday collected $3,101 total for all the activities of surfing and parasailing. 16 people went parasailing, so we're going to use y for 16. So 16 times the amount of how much it costs to go parasailing. 20 people went surfing, so 20 times however much it costs to go surfing. If I add up both of these, this is going to give me the total amount of fees they made, which is $3,101. What we want to figure out is how much does each activity cost. Here's the system. Okay, I know if I take one of each activity, it's going to add up to 175. If I do 20 surfing, 16 parasailing, it's going to add up to 3,101. Now, if you notice, the problem with this is I don't have a y equals or an x equals. I don't know what x is. I don't know what y is. I can't make a substitution. But I can solve for one of them. So look at this equation right here. I don't have, like, x doesn't have a coefficient here, y doesn't have a coefficient. If I just subtracted y on both sides, the y goes away. I'm left with x equals 175 minus y. I now have my variable isolated by itself. I have an x equals something. Now, because I know what x is, I can make a substitution and plug in 175 minus y for x right here. So that's what I'm going to do. I'm going to do 20 times 175 minus y plus 16y equals 3,101. So what I did is, because I didn't have a variable solved for itself, I did it myself. I solved for a variable. And so I rewrote the equation a little bit. I just kind of moved some stuff around. I got x by itself, and then I made that substitution in for x. And now I get to go ahead and just solve my equation. So I get to do 20 times 175, which is 3,500. Minus 20y plus 16y equals 3,101. So let's see, if I combine like terms, that's going to make negative 4y. If I subtract 3,500 from both sides, I kind of did two steps at once there. Okay, but I'm going to do 3,101 minus 3,500. I'm just using a calculator right now, guys, to make this go by a little bit easier. let's see here. Oh, okay. Negative 399. Now I can divide by negative 4 on both sides. And I get y equals $99.75. So what we just figured out is for every parasailing per person is $999.75. Now what I can do is I can pick either one of my equations and plug in my parasailing costs to figure out the surfing cost. I would use this one because this one looks like a lot easier math. So I know it's just going to be x plus 99.75 equals 175. So all I have to do is do a quick subtraction. So when I subtract 99.75, I'm going to get $75.25 for surfing lessons. So there's my x, there's my y. So surfing lessons are $75.25. Parasailing lessons are $99.75. Okay, here's what I want you guys to do. I want you guys to try these two problems right now. See how you do. So pause it, try them, and then we'll talk about it. Okay, so this one you would have noticed might have been some unique circumstances or unique cases. Hopefully we recognize what happens when this happens. So this one I plugged in 3x plus 1 for y here. Then I solved, but when I solved, my 6x minus 6x, they cancel each other out, and I was just left with negative 2 on the left and negative 2 on the right. This means these are the same line, and whenever we have the left side just equal to the right and the variables cancel out, it is infinitely many solutions. So they are the exact same line. Had I converted this to slope-intercept form to graph it, I would have gotten 3x plus 1. They're the same line. Now, when I did the same thing over here, reminder, this is minus y. So when I plugged in 5x minus 4, I still kept it in parentheses because it's minus all of it. So I had to do distributive property here. So 5x minus 5x plus 4, because a negative times a negative is positive. Well, when my 5x's cancel, the positive 4 is left on the right, and negative 4 is left on the positive 4 is left on the left, negative 4 is on the right. These are not equivalent. That means that these are parallel lines. They have the same slope, different y-intercepts. Parallel lines, it means there's no solution. Okay. Now, for A right here, go ahead and try this one on your own. See if you can do B. B looks a little bit different. See how you do on it. And then try that one on your own, and then we'll pause it. And or you can pause it, and then when you unpause it, you'll see the solution. Okay, so for this first one here, I took the y plus 6. It has x equals, not y equals. It doesn't matter which variable we've isolated, right? So I took the y plus 6, plugged it in for x. I did put it in parentheses just to keep that habit, but this isn't being distributed by anything, so the parentheses aren't really necessary. So then I can just combine those like terms and make 2y plus 6 equals 10. And when I solve, I get y equals 2. When I plug in y equals 2 here, 2 plus 6 is 8. Which also works because 8 plus 2 is 10. So my solution is 8 and 2. Now I figured I'd walk you guys through this one. So this one right here, because it's a little different, they're both already in slope-intercept form. So this would be easy to graph. But we're going to worry about substituting. So I can take either one and plug it in for the other one. It doesn't really matter because what's going to end up happening is you're going to have this both sides equal to each other. I'm going to have 4x minus 2 equals 7x minus 5. So yeah, I got the variable on both sides. Just follow our rules of solving equations. Subtract 4x on both sides. I'm left with negative 2 equals 3x minus 5. And now I can just solve from here. So I get x equals 1. So because I get x equals 1, I'll plug that in. 4 times 1 minus 2. Well, that's 4 minus 2, which is 2. So my solution is x is 1 and y equals 2. That would have worked here. If I plug in x for 1 for x here, 7 times 1 minus 5 is 2. There's the bell. Whoops. Okay. Well, let's see here. I think actually I want you guys to do both of these. I want you to do this last word problem for independent practice, and I want you to do this one for independent practice. I think you can handle both of them. Plus, I want to see how you do on the word problem on your own. So we need to write the system first, and then you can figure out the cost. So write this system first and then figure out the cost here. And then on this one, I think you can solve pretty easily. Now, just things to remember, the value of a variable can be an expression, so use parentheses. That's important to use parentheses when we make our substitution. And don't forget to solve for the second variable. Once you solve for one variable in the equation, you need to substitute your solution into the other equation. That's a misstep, common misstep, and it's super important. All right, guys, thanks for watching. I hope this helped. Good to see us out.